In July 2025, astronomers spotted 3i Atlas, a remarkable interstellar visitor racing through the solar system. Its designation marks it as only the third interstellar object ever discovered, first identified by the Atlas telescope. From the outset, it refused to follow the script. Unpredictable and unruly, it has become a magnet for both scientific intrigue and a storm of clickbait speculation. Mainstream models, grounded in the dirty snowball hypothesis, predict that cometary activity should be dominated by sublimation. Ice is evaporating as they approach the Sun. The trouble is, 3i Atlas has consistently defied these expectations. In this video, we'll explore some of its many anomalies: the sunward-facing plume, the early and rapid brightening far from the Sun, the dominance of carbon dioxide rather than water, the nickel-rich rather than iron signature, its non-gravitational accelerations, unusual trajectory, and even the emerging swarm hypothesis. We'll also dive into the alien artifact debate. For researchers in the plasma universe, however, these anomalies are not paradoxes, but opportunities, direct evidence of plasma processes in action. Far from being an oddball, 3i Atlas looks very much like a textbook electric comet coming online. This object is expected to reach perihelion, its closest approach to the Sun, on October 29, 2025, and pass within 1.8 AU, about 269 million kilometers of Earth on December 19th. Close enough for detailed study, but one hopes not too close. By early October, the controversy surrounding 3i Atlas had intensified. Rumours of a cover-up began to swirl as several major space agencies fell conspicuously silent, an unusual pause that only fueled public suspicion. Whispers of politics, secrecy, and conflicting agendas spread across social media and independent channels alike. Then came the images. Released around October 5th to 6th, they appeared to show a long tubular formation. For some, this was confirmation of what they had already begun to suspect, that 3i Atlas might not be a comet at all, but an extraterrestrial construct. However, the apparent elongation may owe as much to the limitations of long exposure imaging as to the object's actual form. For now, let's return to the observable science, because the very anomalies that inspire talk of alien technology also strengthen the case for the plasma universe perspective. To understand what we're really seeing, we must first revisit what a comet actually is. In the electric universe EU model, comets are far more than icy wanderers. They are electrically charged bodies interacting continuously with the Sun's electric field, heliospheric plasma, and the vast Birkeland currents threading through the solar system. These connections produce visible discharges, focused plasma jets, and electrically charged sheaves, often evolving into double layers that sculpt the coma and tail. Conventional comet theory attributes such features to sublimation-driven activity, but viewed through the EU lens, they are expected electrical effects. The familiar image of a comet as a dirty snowball melting in the sun's heat is increasingly at odds with observation. Jets can ignite from unexpected regions, tails can point in directions that defy simple gravity-based models, and outbursts can release vast quantities of material almost instantaneously. In the EU perspective, these phenomena are not random. They are signatures of electric currents flowing through and around the comet, linking it directly to the Sun and the wider plasma environment. Crucially, a comet's electrical activity is not a one-time event or a finite charge that can be used up. As it moves through regions of differing electrical potential, it is continually recharged and discharged, part of an ongoing circuit, not a fading battery. Each change in plasma environment reshapes its sheath, forming and collapsing double layers that release bursts of current. When a coronal mass ejection CME sweeps through, the effect can be dramatic. sudden brightening, sheaf expansion, or sunward spikes as the comet responds to the surge in electrical stress. Understanding comets in this way allows us to reinterpret anomalies like 3I Atlas's shape, activity, and trajectory. Features once deemed peculiar or attributed to improbable collisions now make sense as electrical effects, the formation of plasma filaments, focused ejection of dust and gas, and even the mysterious tubular structure. Hubble images of 3I Atlas revealed a striking plume extending toward the Sun 10 times longer in that direction than across. Harvard astronomer Avi Loeb described it as, quote, unprecedented, even entertaining the possibility of an artificial or alien origin. Why is this so significant? Well, because in classical comet theory, a sunward plume should not exist. Dust and gas are expected to be blown away from the Sun by radiation pressure and the solar wind. A persistent sunward feature directly contradicts the sublimation-based model. Within the electric universe framework, however, this is precisely what one would expect. An electrically charged nucleus immersed in the heliospheric plasma will develop asymmetric discharges concentrated on the sunward side, where the electric stress is greatest. Charged particles are accelerated along electric field lines, guided by the comet's changing potential relative to the surrounding plasma. The result is a luminous, structured plume directed toward the Sun, a manifestation of electric currents, not solar heat. Sunward-directed features have been glimpsed before in other comets, usually as fleeting jets or brief eruptions. But what makes 3I Atlas remarkable is the persistence, scale, and geometry of its sunward extension, characteristics almost impossible to reconcile with sublimation alone. Other distant comets, such as Bernardinelli-Bernstein, have shown early or asymmetric activity that also defies conventional expectations. The pattern is becoming hard to ignore. These are not anomalies, but electrical signatures of an active plasma environment. 3I Atlas entered the inner solar system on a trajectory unusually close to the ecliptic plane, the near-flat disk in which most planets orbit. At first glance, this seems curious, and some have even taken it as potential evidence of extraterrestrial intent. After all, interstellar objects could, in principle, arrive from any direction. A more mundane explanation, however, is at hand. Detection biases mean that objects travelling along or near the ecliptic are far more likely to be discovered early, while those on steeply inclined paths often go unnoticed until they are almost upon us. Even so, the alignment adds another layer of intrigue. The near ecliptic trajectory remains noteworthy, inviting closer scrutiny of what might be shaping its path through the solar system. This path, though, isn't the only thing raising eyebrows. Adding another twist, Avi Loeb has pointed out that the trajectory of 3I Atlas appears to trace back to the same region of sky from which the famous WOW signal was detected in 1977, a powerful unexplained radio burst recorded by the Big Ear telescope in Ohio. The coincidence is fascinating, although it remains, as far as we know, just that, a coincidence. Still, it's a poetic echo, two cosmic mysteries whispering from the same patch of sky, half a century apart. Polarimetry, measuring how light is polarized, reveals much about cometary dust. 3I Atlas shows an unusually deep, narrow, negative polarization branch. The angles and minima point to large grains made of ice mixed with dark, absorbing material. In the plasma universe view, grains with different conductivities respond in distinct ways to charging, acceleration, and plasma currents. This produces the complex polarization patterns we observe, patterns that the classical sublimation model struggles to explain. Like 2I Borisov before it, 3I Atlas displays polarization signatures that hint at electrically active dust, challenging the assumptions of classical comet theory. The carbon dioxide-rich coma of 3I Atlas overturns classical expectations. In solar system comets, water usually dominates near perihelion, with CO2 making up only 10 to 20% by comparison. But Sphere X and JWST observations show CO2 rivaling or even exceeding water in this interstellar visitor. In the plasma universe view, electrical discharges on the nucleus can liberate CO2 far more efficiently than sunlight alone, producing asymmetric plumes and unexpected ratios without invoking exotic ice chemistry. The comet's changing colour strengthens this interpretation. As 3I Atlas brightened, it shifted from shades of blue to vivid green, the hallmark of carbon molecules excited under electrical stress. Rather than a chemical oddity, this glow is diagnostic, a predictable consequence of a charged body interacting with plasma. Classical comet theory often invokes sublimation-driven jets to explain orbital deviations, yet 3I Atlas exhibits accelerations inconsistent with simple outgassing. The plasma model provides a natural explanation. Charged dust and ions, accelerated by local electric fields, produce the observed motion, acting as a cosmic thruster. Abrupt brightening episodes and filamentary jets follow naturally from plasma interactions rather than improbable sublimation events. Equally, these interactions can also account for episodes of anomalous slowing, and electrical surges also help explain the sudden bursts of light. Classical explanations blame sudden exposure of volatile ices or phase changes for rapid brightening. The plasma model, by contrast, points to electrical thresholds. As a comet moves into regions of higher heliospheric potential, currents build. Once a critical threshold is crossed, an electrical discharge or avalanche ignites surface material, blasting dust and gas into space. From a plasma or electric universe perspective, a connected living cosmos, we might expect our own galaxy, the Milky Way, let alone the wider universe, to be teeming with life. The trouble is, when the alien hypothesis becomes a free variable to explain every anomaly, one has to smile. In the case of 3I Atlas, exotic technologies have been invoked to fill the gaps left by failed predictions. It makes for compelling headlines, but rarely for sound science. There are even claims that 3I Atlas's strange sun-facing plume might not be natural at all, but a beacon, an artificial light crafted by unknown hands. The notion is entertaining, but it strains belief. Why would a civilization capable of crossing the stars choose to hitch a ride on a lump of rock or, if you prefer, a dirty snowball? To be fair, anomalies abound. 3I Atlas also shows an unusually high bulk density and a peculiar nickel to iron ratio, both serious problems for the dirty snowball hypothesis. An object supposedly made of fragile ice and dust should not register such compactness, nor should its metallic signature diverge so sharply from that of solar system comets. These features alone invite speculation that ventures beyond the natural. As Harvard astronomer Avi Loeb noted, yes, him again, quote, "Perhaps it is natural, but we have to allow for the possibility that it is technological." The electric universe perspective reframes these mysteries in natural terms. Comets are far more than icy wanderers. Plasma interactions, electric fields, and heliospheric currents can produce precisely the effects that classical astrophysics struggles to explain. Where the alien hypothesis entertains, the EU model explains, offering testable mechanisms rooted in physics. Let's not forget, too, we had much the same speculation about the first interstellar visitor, Oumuamua, after its 2017 discovery. Rumours that resurfaced in 2024 with a fresh round of headlines and debate. Regardless, for all the attention lavished on the alien angle, another question looms. Why do genuine predictive successes so often go unacknowledged? Will the electric universe ever get credit for its predictive hits? Don't hold your breath. Even the Y-Files, a channel usually open to alternative ideas, dropped the ball on this one. In their 2023 Electric Universe episode, host AJ implied that the late Wallace Thornhill had no real scientific credentials, portraying him as a salesman, and claiming that no record of his comet predictions existed before NASA's Deep Impact mission. Really? A 2-minute search would have cleared that up. Thornhill has his own page on the prestigious IEEE Institute of Electrical and Electronic Engineers website. He received his BSc in Physics and Electronics from Melbourne University, Australia in 1964, and spent much of his career in software for IBM, not sales. Moreover, his predictions are well documented. Additionally, in July 2013, he was awarded the prestigious Sagnac Award for Lifetime Achievement at the 20th Annual Conference of the Natural Philosophy Alliance. Perhaps AJ, a former government employee, hoped viewers would take him at his word. As Simon and Garfunkel reminded us in The Boxer, quote, "A man hears what he wants to hear and disregards the rest." To be fair, AJ always opens with a disclaimer, quote, "What do I know? I'm just a man who talks to a fish. I make mistakes." Fair enough, but this one was a whopper and entirely avoidable. Before Deep Impact launched in 2005, Thornhill went on record with several specific testable predictions based on the electric comet model. He said the impact would produce a brighter than expected electrical flash before contact, and that the resulting crater would be far smaller than predicted. Outcomes incompatible with the standard dirty snowball hypothesis. Guess what happens next? When the mission unfolded, that is precisely what happened. NASA scientists were caught off guard. One even admitted on camera, quote, "I'm at a loss to explain it." These effects, of course, resulted from the electrical interaction between the approaching spacecraft and the comet's plasma sheaf. Thornhill had also predicted a brief interruption in the impactor's transmission, caused by the sudden potential difference between the two bodies. The electrical discharge effectively created a cushioning effect, also disrupting the signal just before impact. More recently, as already mentioned, both NASA and ESA appeared notably quiet when 3i Atlas passed close to Mars. Was a similar electrical interaction observed and quietly set aside? Time may tell. Thornhill and other EU proponents have long argued that the narrow filament-like jets, high-temperature hotspots, and sharply sculpted surfaces observed by spacecraft are far more consistent with plasma discharges than with sublimation alone. Later, Matt Finn revisited Thornhill's predictions in the Thunderbolts project episode Set the Record Straight, showing how the deep impact data quietly confirmed what Thornhill had said all along. As Thornhill himself put it, quote, "All the things we see around comets fit the electrical model, but don't make much sense in terms of icy snowballs sublimating into space." And in one line that grows truer with every mission, quote, "It is surprising that they continue to be surprised by all the surprises," end quote. In 1950, following extensive study of ancient myths and comparative traditions, Immanuel Velikovsky advanced a bold and controversial hypothesis that Venus had not always occupied its current orbit, but had entered the solar system as a luminous comet-like body, perhaps ejected from Jupiter or Saturn before stabilizing in its present path, all within the span of human memory. To proponents of a stable and orderly solar system, such a notion was anathema. Velikovsky's ideas were swiftly branded pseudoscience and cast aside. Yet Velikovsky went further. Among others, he made these two specific predictions. One, that Venus would prove to have an extraordinarily high surface temperature, and two, that its atmosphere would be dominated by carbon dioxide. When space probes arrived decades later, both were confirmed in detail. Although his larger reconstruction remains controversial, the lesson endures. An outsider following overlooked clues anticipated discoveries the establishment never saw coming. In the same spirit, the electric comet model has long predicted features such as filamentary jets, explosive brightening, sunward plumes, and unexpected volatile signatures. These phenomena continue to confound the dirty snowball paradigm. Although Velikovsky was sidelined and ridiculed by orthodoxy, some high-profile scientists were more generous in their appraisal of his work. As widely cited, the famous geologist Harry Hess wrote to him in 1963, quote, "You have, after all, predicted that Jupiter would be a source of radio noise, that Venus would have a high surface temperature, and that the Sun and other bodies of the solar system would have large electrical charges, and several other such predictions. Some of these predictions were said to be impossible when you made them. All of them were predicted long before proof that they were correct came to hand. Conversely, I do not know of any specific prediction you have made that has since proven to be false. I suspect the merit lies in that you have a good basic background in the natural sciences, and that you are quite uninhibited by the prejudices and probability taboos which confine the thinking of most of us. Whether you are right or wrong, I believe you deserve a fair hearing. End quote. Today, as new comets light up the sky, that same fair hearing is long overdue. The mystery deepened in September 2025 with the sudden arrival of Comet C 2025 R2 Swan. First spotted by SOHO's Swan instrument, it appeared almost out of nowhere, already bright, already active, and racing through perihelion scarcely hours after discovery. By then, it carried a fully formed tail and a luminosity that slipped neatly through the fingers of sublimation theory. Its orbit reveals a long-period wanderer, likely tens of thousands of years in the making, yet its behavior mirrors that of 3I Atlas: sudden ignition, volatile outbursts, and a plasma-dominated tail, all signatures of electrical processes that conventional models struggle to explain. Together, these two comets pose a troubling question. Are they rare coincidences or fragments of a larger hidden swarm now drifting into the inner solar system? The comparison is telling. Swan passed much closer to the Sun, where heating effects undeniably played a role, and its near-Earth passage allowed astronomers to study its plasma features in detail. 3I Atlas, by contrast, was tracked for months before it neared the Sun, displaying electrical activity far beyond the reach of thermal sublimation. One revealed its secrets late, the other early. Both, however, defied the dirty Snowball model. And they are not alone. Comet Lemon is also threading its path across the sky, while ever faint visitors slip through the system largely unnoticed. The pattern, though subtle, is there. Multiple comets appearing in quick succession, behaving in ways that point to electricity, not evaporation, as the driver of their activity. If these objects are part of a broader swarm, the implications extend beyond astronomy. Electrically active comets can stir the solar plasma environment, triggering heightened solar outbursts. On Earth, the effects may cascade through the magnetosphere, producing brilliant auroras, disruptions to satellites and power grids, and, as some studies cautiously suggest, even correlations with increased seismic or volcanic activity. 3I Atlas offered astronomers something unprecedented, an interstellar object observed in real time, revealing chemistry, morphology, and dynamics that defied every expectation. With the arrival of Swan, the pattern is no longer a curiosity, it's reinforced. The importance of these comets lies not in their individuality, but in their shared defiance of conventional thinking. One anomaly can be dismissed, two or more form a pattern, and in science, patterns demand attention. Yet mainstream astronomy seems more willing to speculate about aliens than to confront its own failed assumptions. The plasma universe, by contrast, sees a coherent story emerging, the unmistakable imprint of electricity in motion. Together, 3I Atlas and Swan force a question the traditional model can no longer evade. What if comets are not inert leftovers, but active participants in a charged solar system? If that is the case, the dirty Snowball model is not so much incomplete, it's obsolete. Comets have long been called the Rosetta Stones of creation, cosmic messengers preserving the story of our beginnings, but perhaps we've been reading them in the wrong language. Their true script may be written not in ice and dust, but in plasma and charge.